Hello everyone, welcome to the WP6 Health Application Use Case Training. In this session, we will explore how the alternative ETL tool integrates seamlessly with EXA4MIND platform to enable secure, scalable healthcare data mining and transformations. Let me start by introducing myself. I'm Asif Sayed, a data scientist specializing in healthcare data and AI implementations at Alternative. As part of the EXA4MIND project, our mission is to showcase and maximize the platform benefits for small and medium-sized enterprises, especially those in healthcare sector. Before we get started, here is a quick look at the agenda for this training. We'll start with the basics of alternative ETL tool and see how ETL works with healthcare data transformations. Then we'll also get introduced to the EXA4MIND platform Extreme Databases, integration with alternative ETL tool, and securing of those healthcare data pipelines. We'll explore the real-world use cases of ETL data pipelines for demographic analysis and disease tracking. By the end, you will have a clear picture of how this ecosystem empowers high-performance healthcare data solutions. Before diving into the tool itself, let's understand the broader context. What is ETL? ETL stands for Extract, Transform, Load, a core process in data engineering that involves gathering the raw data from various sources, cleaning and converting it into the usable format, and then loading it to the destination systems such as data analytics platform, etc. In the healthcare domain, ETL is essential for integrating data from diverse systems like electronic medical records, lab systems, billing records, and IoT, etc. This data is often complex, inconsistent, and highly sensitive. ETL plays a critical role in standardizing, validating, and securing this information, making it ready for analytics, clinical decision support, and preparing the dataset for machine learning applications. So, what is Alternative ETL Tool? Alternative ETL Tool is a visual low-code, no-code platform designed to help you build efficient data pipelines with ease. Using a drag and drop interface, each processing box handles a specific task like importing, transforming, or exporting the data. It is built to process even massive data sets quickly and reliably, so you can focus more on insights. Alright, let's jump into the live demo and see how it actually works. Let's begin with the login screen. Here, users simply enter their credentials to securely access the ETL platform. The login process is quick and fully browser based. Once we are logged in, this is what the main dashboard looks like. Right up top, you can see the main navigation menu, dashboard, pipelines, files, and users, giving you full access to everything from building workflows to managing data and user permissions. Below that, we have got live resource monitoring, showing how much CPU, memory, storage your ETL workflows are currently using. This is super helpful for tracking performance, especially when you are working with large healthcare datasets. On the left, we also have WP6 Health S3 bucket mounted as a data source. This is part of the EXA4MIND EDD integration. It allows us to directly access, extract, and transform raw data that has been uploaded to the S3 bucket without needing it to move files manually. This makes the workflow highly efficient, especially for handling large volumes of datasets in real time or batch mode. In the center of the screen, you will notice recently opened pipelines. This provides a quick access, allowing to jump straight into the workflow with a single click without navigating through the main menu. Now let's head over to the Pipelines tab. This is where all your ETL projects live. On the left panel, you can see categories like projects, drafts, published, in production, and more. This helps you quickly organize and filter your work based on its status. In the center, we have list of available pipeline projects. Each row shows the name, current state, version, and author of the pipeline created. You will also notice some are in draft mode, still being built, while others are already published, meaning they are finalized and ready for production use. For example, we have projects like E4M underscore transformation underscore CSV, E4M underscore CSV underscore RDBMS, and E4M underscore insights, all published and built by different team members. You can also mark pipeline as favorite with the star icon here on the right side of the screen. In order to search quickly and find your project using some regex pattern, you can search it from this box. And if you want to start something new, just click on new project button on top left to begin and build a new pipeline from the scratch. Now let's switch to the Files tab. This is where all your project files, datasets, and sources are organized. On the left panel, you can see the structured folder system. These folders are created for this project inside the EDD of EXA4MIND. The folders like demographics, healthcare facilities, consent form, and even pre-cleaned datasets all are mounted to the ETL. We are currently looking at the shared folder. Here we have two files, and you can see their file size, even mark them as favorite using the star icon on the right. At the top, you will find options to upload new files, add data sources, create folder, or filter file types. The search bar also supports regex, making it easy to locate specific files, even in large repositories. What's great is that once a file is uploaded here, it can be directly used in your data pipelines. No need to re-upload or transfer files between the tools. Now let's take a quick look at Users tab. This is where access control and user management happens. Here you can see the list of registered users along with their email addresses and assigned roles. In this example, we have a list of users who are all part of this project team. Each user can be enabled or disabled using toggle switch, making it easy to manage temporary access without deleting the account. Clicking on any user or this icon opens up their setting panel. Let's look at Stefan's profile as an example. Here you can view or edit user roles, like setting them as a basic user or manager, and configure fine-grained permissions. For instance, Stefan can have access to write pipelines, write actions, write files, and generate reports and manage jobs. You can also control the data access by selecting which folders or data sources that user can work with. In this case, I can allow Stefan to have access to demographics and address registry. Once everything is set, just click update to save the changes or cancel if no modifications are needed. In a healthcare setting, this levels of control is especially important. It ensures sensitive data like patient records or demographics data is only accessible to the authorized person. which helps with data privacy, compliance with regulations like GDPR, and overall system security. It also supports seamless collaboration across research, clinical, and technical teams without compromising the data governance. Welcome to the quick demo of alternative ETL tool integration with EXA4MIND EDD ecosystem. To start, we'll see how the ETL tool connects to the Minayo S3 bucket and what it looks like inside the interface. In this case, it is the WCP6 health bucket. Mounting the bucket allows the tool to access raw healthcare data directly from the cloud. Now let's move on to the PostgreSQL integration with the ETL tool. Here we have a PostgreSQL box inside the ETL interface, which is designed to handle the data ingestion into a PostgreSQL database. This is the configuration panel where we set up the connection including IP address, username, table name, and other required parameters. The password is securely managed using secrets, ensuring safe access to the ETL EDD databases. Let's run the pipeline and see the data being ingested into the PostgreSQL in real time. In the bottom left corner, we have logged directly into the PostgreSQL terminal to monitor the live data ingestion. This pipeline shows the Lexis dataset integration with ETL tool, which allows us to upload clean data directly from S3 to Lexis environment. In the log window below, you can see files are being uploaded in real time. Now let's move over to the Lexis portal to verify that the files have been successfully uploaded. Now let's begin with some practical exercises and see everything in action. Welcome to the practical exercises using the alternative ETL tool integrated with EXA4MIND platform. In this session, we will explore the hands-on usage of alternative ETL tool and using the integrated EDD databases of EXA4MIND. Before we jump into the tool, let's first understand how the boxes are arranged in the ETL tool. The boxes in the ETL tool is structured into three main sections: input, transformation, and output. Input connectors let you pull the data from various sources such as files, databases, and cloud storages. Transformations block help you clean, filter, join, and analyze the data through a visual interface. And finally, output connectors allows you to export the process data directly into the EDD databases like S3, Postgres, or Lexis datasets. Now let's create our first pipeline and see how the transformations can be done. Navigate to the pipeline section from the main menu. Click on New Project, then enter name and description for your project. Click on Create to create your project and enter the folder we just created and click on the New Pipeline option to create a new pipeline. Give it a clear name and description so it's easily identifiable when collaborating with other team members. Once you enter the necessary information, you have an option to just create the pipeline or create an open. So let's create an open. Once you are into the pipeline workspace, on the right hand of the screen, we have main action panel. This is where you will find all the building blocks for your ETL workflow with different type of boxes divided into three main sections: the input, transformation, and output. Now let's see how we can read different files from S3. Now let's add our first input box, in this case read CSV box, to load the data from CSV file. You can find it under common inputs or simply search for read CSV using the search bar. Then just drag and drop it onto the canvas or workspace. Double click on read CSV to open the configuration panel. Once you have the configuration panel open, you have an option to choose the folders and the files. So here let's select the Malta and CSV file inside the folder. And now we have this CSV file selected. Now we can either view or create a cache of the file read to till this point so that we can verify the data and validate. We'll start by previewing the data first. So when you click on this icon, it reads the whole Excel file and it will show you the data what's inside. So this is the synthetic data which we generated for demographics. So here the whole data set what you see here, these are the fake names and date of birth and their nationality. And now you can create cache till this point in order to run the whole data set at once. For example, here you can see it has created the cache till this point. And yes, so now we know that this box has done the whole task assigned to it, and now it has the output of the action as a cache stored into its memory. Either we can clear the cache or we can view it again. This time it will be faster since the whole output is stored inside the cache. So now let's try to read one more file type. In this case, we'll try with read Parquet. We'll try to read one Parquet file format. Let's select the data source where these files are available and select the Parquet file and double click. So this is the data which is available inside the Parquet file. By default, this window will show you the top 100 rows of the dataset. If you want to view more data, you just have to create a cache at this point and go to the line numbers and verify the dataset from there. Now we will take a look at how to read multiple files available in the folder and transform to extract the insights. Now let's see how we can read multiple files and transform the data and explore the data set. So here we were looking at only one file, which was age group data male Maltese. So we were reading only one CSV file earlier. Now if I want to read the whole data set or all the files available inside this folder, what do I have to do is just select a file and just make sure we are following the naming convention for the files and mention the wildcard while reading the file name. Now once we click here, now it will read the whole data set or files available inside that folder. So now we can see the top 100 lines of the file or the dataset. So if I want to look at the whole dataset, I have to create the cache at this point. Now this will build a cache And here, once I go here, now it is giving me the option to the explore data set from the line numbers. So I can I can specify the line number here and click on go. So now it will take me to that line number so that I can explore the data set from there. So this is how you can explore your data set line by line in order to see the data quality. Now let's try to get an overview of this data set. We'll use one aggregation box to compute the aggregation like count, sum, mean, median. Let's connect this box to the first point of this aggregate box. Sorry, here, okay. So now let's enable the option create a count column so that we know how many lines of data sets we have here. Okay, now click. Let's verify. Here it's more than 668,000 lines of data set. So what I can do is I can copy the same number and go to the line and verify. Yeah, this is the last line in the data set. I can just modify the number and explore further. Now let's see how we can extract more insights from this dataset. Let's suppose if I want to explore the data further, I can use the same box and simply enable additional settings. For example, if I want to know the gender distribution of this dataset, so I can configure here. So this is the pin from where I want to get my input data, and I'll want to select the gender and move it to the right side of the selection. Once it moved, just validate and run the box. So now here you can see the gender distribution of this data set for male and female. In this way, you can view your data set at each stage of this workflow to make it clean data set for machine learning applications. In this section, we will demonstrate real-world use case pipelines developed as part of the EXA4MIND project. Let's walk through the real-world ETL pipeline built for this EXA4MIND use cases. So it's divided into three main sections: reading the data from S3, data cleaning and enrichment, and writing the data to S3. So we start from the read CSV box. The first read CSV box, this is used to read the raw data directly from the S3 bucket. You can click on this box to preview the files which is reading from, and you can click on the second box to see the data. This is an address data which we downloaded from OpenStreetMap to demonstrate how we can enrich the data combining the demographic information with address details. Now second part of this pipeline, which is a cleaning and enrichment stage of this data pipeline. Here it's sorting the data coming from the read CSV box based on the place of birth, and here in this box it is sorting the data which is coming from read CSV box of address registry is based on ID column of this box. So here, while generating the data, we have taken this ID column as a common, as a place of birth. So it's not only the numbers, so you can also join the columns based on the text. So here we are joining the place of birth from the uh, sort box to the ID column of the second sort box. So if you see here, it has merged the uh, the name, gender, nationality, ID, patient, date of birth, place of birth with the address registry. So this is an address data which we downloaded, which is coming from the second CSV file. And if you see here, it's a lot of data, and there's some data which we don't need in our pipeline. For example, if you want to clean the data. So next here, we are sorting it again based on date of birth. And if we run this, you'll see the data sorted here. Okay. Now we want to limit the columns, and we want to take some meaningful data out of all these columns. So let's say, for example, we have the select box here. Once you click here, you will see the whole columns coming from the input pin, and we just selected few columns which we think as meaningful for our data enrichment, just from the date of birth, name, latitude, longitude, country code, time zone, etc. And once we click here, it will it will be showing only the columns which we selected, not all the columns which are which are merged initially in the join section of this enrichment pipeline. So now you can see here is a clean data. We can consider this name as a city name, etc. So now we can rename the column to so standardize the column name so that we can use this data to ingest into the databases. So here we just rename the column from first name with capital letters to small in the lowercase. So the last name from mix caps and lowercase to lowercase, and so on. So if I click here, now you will be seeing the whole column names changed into the lowercase. Now the third stage of this pipeline, we will be writing the data back to the S3 as a clean data. So in order to do that, first we have to write the uh, file into the temporary location, the output file. So once the whole pipeline runs, all these blocks are executed, the data will be returned to the temporary location. And from this temporary location, we just have to mention the correct file name here. So we will list the files from this temporary location with the help of this list file box. And then we will write these files to the source. So with the right to source box. So here, if you can see, we have clean data EDD. This is the folder which is available in the S3 bucket of WP6 Health. So once we run this pipeline, let's run this pipeline and wait for this pipeline to finish. Once it's completed successfully, we will be able to find our output file inside the clean data EDD folder here as population underscore Malta as an output file. So this is how we do transformation and save the data back to S3. Now let's take a look at the demographics inside extraction pipeline. In this pipeline, we'll be extracting the information and insights from the population underscore malta.csv file, which we just cleaned and saved into the EDD S3. Ensure the correct file path is set before the execution and run. Here is the result of box execution, allowing us to review the first 100 records. Click on the calculator box to add date of birth column and calculate the age. Here it's already added. We are going to apply an expression that calculates the age by comparing the date of birth with current date. Now run. Once the box is executed, you will find a new column created with an age. This is the age calculated from date of birth for each record. Now we are in aggregate box. Here we are grouping the data by three variables: nationality, gender, and age. These are added under the group by section. We have also enabled the option to create a count column, which will help us summarize how many records falls into each group. Run the box to process the full dataset. Once it's done, we will have the complete summary of demographic details for all individuals by nationality, gender, and age group. Use the sort box to sort the data in ascending order before writing it to CSV. As you can see, the data is now sorted in ascending order by age. To save the results, you can follow the same steps used earlier in previous pipeline to export the CSV file to S3. Let's move to the final data pipeline in this training. In this pipeline, we are going to trace communicable diseases using HIE and immigration data. Before we explore the data, let's have a quick overview of the workflow. This pipeline starts by loading two datasets, HIE data at the top and immigration records at the bottom using the read CSV boxes. The HIE data is filtered by diagnosis code such as ICD-10 through the filter rows box. Both datasets are then sorted individually to ensure a structured and clean join. The join box merges the filtered HIE data with immigration records. We then use the select column box to retain only the relevant fields for analysis. Let's click through the boxes one by one to review and validate the data transformations throughout the pipeline. This is the HIE data, and this is the immigration data, which both are synthetic data which we generated with the scripts. Now here we will filter the rows with specific ICD-10 number, which is U0.71, which is related to COVID. Now we'll sort the boxes. This is a mandatory action before joining any two data sets. So here is the complete merged data set. So now we'll select some columns since we don't need all the data. So here we have necessary data which we require to calculate the date. So now here we can calculate the immigration date to the visit date to the clinic or hospital and the number of days it took between immigration and the hospital visit. These insights can be directly shared with public health departments, hospitals, and relevant authorities responsible for managing public health. In summary, this pipeline enables efficient data integration and analysis, supporting critical public health interventions and decision making. In this session, you have learned how to use the alternative ETL tool to design the scalable data pipelines, control user access, and work with integrated EDD databases within the EXA4MIND. These foundational skills enable you to transform the raw data and complex datasets into clean, actionable insights, laying the groundwork for machine learning applications and smart public health decisions. We appreciate your engagement and we are excited to see the innovative solutions you will build using these tools. Thank you.